Alright, we are going to not cover Chapter 4 in depth, but quickly hit the highlights of terms you need to be familiar with and that kind of thing. So Chapter 4 talks about your entity relationship modeling. It's going to talk about the main characteristics of an entity relationship components, how relationships between entities are defined, refined, and incorporated into your database design, how ERD components affect database design and implementation. Real-world database design often requires the reconciliation of conflicting goals. So your entity relationship model, or ERM, we talked to this a little bit about this already. The basis of an entity relationship diagram, or ERD, it represents the conceptual database as viewed by the end user. ERDs depict the database's main components, entities, attributes, and relationships. Because an entity represents a real-world object, the word entity and object are often used interchangeably. Thus, the entities or objects in the examples in the book include students, classes, teachers, and classrooms. The order in which the ERD components are covered in the chapter is dictated by the way the modeling tools are used to develop ERDs that can form the basis for successful database design and implementation. Recall that an entity is an object of interest to the end user. Alright, you learned in Chapter 2 the ERM modeling level. An entity actually refers to the entity set and not to a single entity occurrence. In other words, an entity in the ERM corresponds to a table, not to a row. In the relational environment, the ERM refers to a table row as an entity instance or entity occurrence. Attributes are characteristics of entities. For example, the student entity includes the attributes student last name, student first name, and student middle initial, among many others. Alright? It shows in your book on page 107. I don't know if this is in your slides. And on 107, it shows you chin and crow's foot models for attributes of students. The different way to diagram it there. Alright, so required attribute is an attribute that must have a value. In other words, it can't be left empty. An optional attribute is an attribute that does not require require a value and can be left empty. Attributes have domains. A domain is a set of possible values for a given attribute. For example, the domain for a grade point average attribute is written as being between 0 and 4, because the lowest GPA value is 0 and the highest value is 4. Attributes can share a domain. For instance, a student address and professor address share the same domain of all possible addresses. Identifiers. ERMs use identifiers, one or more attributes that uniquely identify each entity instance. In the relational model, entities are mapped to tables, and the entity identifier is mapped to the table's primary key. Identifiers are underlined in ERD. Key attributes are also underlined in a frequently used shorthand notation for the table structure called a relational schema. Here's the diagrams of your student using chin and crow. In chin, attributes are represented by ovals and are connected to the entity rectangle with a line. Each oval contains the name of the attribute it represents. In crow's foot notation, the attributes are written in the attribute box below the entity rectangle. Because the chin representation consumes more space, software vendors have opted to crow's foot displays. Alright, a composite identifier is a primary key composed of more than one attribute. For instance, the tiny college example we've been using, database administrator may decide to identify each class entity instance by using a composite key of the course code and class section instead of using just a class code in general. Composite and simple attributes. A composite attribute, not to be confused with a composite key, is an attribute that can be further subdivided to yield additional attributes. For example, the attribute of address can be divided into street, city, state, and zip. Alright, a simple attribute is an attribute that can't be divided, for example, age, sex, gender. Alright, single valued attributes, an attribute that can only have one value. For example, a person can only have one social security number. A manufacturer part can only have one serial number, and that kind of thing. A multi-valued attribute are attributes that can have many values. For instance, persons may have several college degrees, and a household may have several different phones or phone numbers. Here for multi-valued attributes, there's your diagram of how to implement that in Chin and in Crow's Foot. And it tells you here multi-valued attributes have many values and require creating several new attributes, one from each component of the original multi-valued attribute. A new entity composed of the original multi-valued attributes components. Derived attribute is an attribute whose value is calculated from other attributes. The derived attribute need not be physically stored within a database. Instead, it can be derived using an algorithm on the fly. Here's a depiction of a derived attribute. Derived attributes are sometimes referred to as computed. Computing a derived attribute can be as simple as adding two attribute values located on the same row, or it can be the result of aggregating the sum of values located on many rows. Advantages and disadvantages of storing derived attributes. An advantage was save CPU processing, save data access time, data values readily available, and can be used to keep track of historical data. If it's not stored, it saves storage space, and computation always yields the most current value. Disadvantages of being stored: it requires constant maintenance to ensure derived value is current, especially if any values used in the calculation changes. And disadvantage of it not being stored: it uses more CPU processing cycles, increases data access time, and adds coding complexity to queries. The association between entities that always operate in both directions. Participants are entities that participate in a relationship. And each relationship is identified by a name that describes the relationship. The relationship name is an active or passive verb. For example, a student takes a class, a professor teaches a class, department employees a professor, a division is managed by an employee, and so forth. Connectivity. The term for connectivity describes a relationship classification. When we talk about how they're depicted in Chin and Crow's Foot, that's connectivity. When you look at the different notations and how everything is classified. Cardinality expresses the minimum and maximum number of entity occurrences associated with one occurrence of a related entity. In ERD, cardinality is indicated by placing the appropriate numbers beside the entities using the format of paren x, y paren. The first value represents the minimum number of associated entities, while the second value represents the max number. And here it shows your connectivities and your cardinalities in this diagram. Alright. Existence dependence. An entity is said to be existence dependent if it can exist in the database only when it's associated with another related entity occurrence. In implementation terms, an entity is existence dependent if it has a mandatory foreign key. That is a foreign key attribute that cannot be null. If an entity can exist apart from all its related entities, then it is existence independent and is referred to as a strong entity or regular entity. For example, suppose the XYZ Corporation uses parts to produce its products. Furthermore, suppose that some of those parts are produced in-house and other parts are brought from vendors. In that scenario, it is quite possible for a part to exist independently from a vendor in the relationship. Part is supplied by vendor because at least some of the parts are not supplied by the vendors. Therefore, part is existence independent from vendor. Alright, a weak or non-identifying relationship exists if the primary key of the related entity does not contain a primary key component of the parent entity. By default, relationships are established by having the primary key of the parent entity appear as a foreign key on the related entity. Okay. A strong relationship or identifying relationship exists when the primary key of the related entity contains a primary key component of the parent entity. And it gives an example there. In this case, the class entity primary key is composed of the course code and class section. Therefore, a strong relationship exists between course and class because course code, the primary key of the parent entity, is a primary key component in the class entity. Okay? Alright, here it shows a weak relationship between course and class. And there it shows a strong. Alright, a weak entity is one that meets two conditions. First, the entity is existence dependent. It cannot exist without the entity with which it has a relationship. And the entity has a primary key that is partially or totally derived from the parent entity in the relationship. Database designers determine whether an entity is weak-based or business-ruled. Here it shows a weak entity. We're not going to look at this. Mandatory. You can just basically know what it is. An optional participation is when an entity occurrence does not require a corresponding entity occurrence in a particular relationship. And mandatory is when an entity recurrence requires a corresponding entity recurrence. Okay? And there it shows some symbols. Alright, relationship degree indicates the number of entities or participants associated with a relationship. A unary relationship association is maintained within a single entity. A recursive relationship exists between occurrences of the same entity set. In a binary relationship, two entities are associated, and in a ternary, three entities are associated. And here it shows some examples of the types of relationship degree. Here it shows a representation of a recursive relationship. Alright, associative entities, also known as composite or bridge entities, used to represent a many-many relationship between two or more entities, is in a one-to-many relationship with the parent entity, composed of the primary key attributes of each parent, may also contain additional attributes that play no role in connective process. Then it talks about developing your ER diagram. I'll let you look over that yourself if you're interested in working on developing your own ER diagram. We're not going to go into in depth on that. I think it talks a little bit about challenges to database design. Of course, you can have conflicting goals. Database design must conform to design standards. The need for high processing speed may limit the number and complexity of logically desirable relationships, and the need for maximum information generation may lead to loss of clean design structures and high transaction speed. Okay, this was just a quick overview of some terminology and concepts in Chapter 4. We're not going to do an assignment in Chapter 4 or anything like that. I just want you to be familiar with the terminology of an entity relationship model. If you have any questions, let me know. By all means, you need to read through the chapter, especially the sections that I talked about for the terminology. And again, let me know if you have any questions.